Hello everyone, welcome back to another GIS lecture video. And in this lecture video I want to continue our discussion on visual variables by talking about the idea of size. So let's give ourselves a little bit of space here and let's start talking about size. So size is, in my opinion, one of the most straightforward visual variables. And basically what we're doing is we're changing the size of the symbol in relation to the data. So for points, right, we might have a symbol be this size, we might have a symbol be this size, and we might have a symbol be this size, right? The difference in size between these, right, that's the visual variable size. Right, for lines, right, we might have a line be, let's use the size built into the software. We might have something like that, and maybe we jump up to something like that. Right, the width of the line here, the difference in width, this is size. Right, let's go ahead and define that actually a little more clearly here. Right, difference in width is size. Right, now you might be asking, well, what about polygons? Now, as a general rule of thumb, I don't use the size visual variable with polygons. What I tend to do is I tend to convert the centroid of the polygon to a point and then use size for the points because it's just much easier. But what you can do for polygons, if you really wanted to keep the polygon geometry exclusively, is you could use a pattern that had dots of some sort in the pattern and then make those dots bigger and you can see why I would say just converting them to a single point at the centroid would get the same point across. But with polygons, right, you can increase the size of the individual symbols that make up the pattern versus points are a single symbol, so you increase the size. With lines, you just increase the weight or the width of the line for size. So, how does size fit into quantitative versus qualitative? Well, here is, again, where we have the idea of size having an implicit sort of perceptual connection, right? People tend to assume that larger things are more important. Or that on a scale, right, larger means more. Meaning, right, if we have differing size points, people are naturally going to assume that as long as they're part of the same data set, that a point that has a larger size is going to represent a larger value or a higher ranking or whatever than a smaller point in the same data set. Meaning, size is not useful for nominal data. Right? It is somewhat useful for ordinal, and it's definitely useful. In fact, one whole symbology type or map type we're going to talk about is graduated symbols, which literally deal with using size as the visual variable. So we're going to come back to this idea with graduated symbols. And we'll talk about this in far greater detail in a future video. But needless to say, size is useful, again, just like with spacing, right? Size for ordinal only. And definitely, let's not have that be quite so far down. Size is definitely useful for quantitative. So hopefully that makes sense, the way that we can make symbols bigger, or in the case of polygons, the symbols within the patterns bigger, to represent differences in the underlying data using the visual variable size. And as always, if you have any questions, please reach out. Thank you.